Welcome back to our MySQL discussions. As stated, we're going to take a look at group by and having, two clauses that often work with aggregate functions. First, we're going to look at group by, and then we'll see how having has interplay with group by. On to some examples. So I'm going to select the first three queries here in my editor. And if I use the lightning bolt here, it'll just run the first three queries so we can get a smaller set to understand them. So the first, I just want to show the general layout of the orders table. Also all orders, all columns. And notice that we have a status that we're going to look at in the next two queries. The status here, we have shipped. It's pretty typical. Shipped, canceled, resolved. A lot of times for a should be in progress status in a normal system. I don't know if they have that here. But you can see the list of order statuses are in process. Yeah, there we go. Disputed, on hold. Typical for an ordering system, actually, for this status column here. So select star from orders. Again, every column, every row. So now when we use group by, and as we stated, group by is normally used with an aggregate function. And here's a use, though, to first understand it, a use without an aggregate function. So it forms groups. So let's take a look at query number 2 here, orders 4. So all possible queries. So once it forms a group by status, then that's it. So all the orders that had that status fit within that category. So the category appears once. Notice that this is logically identical to the distinct keyword. Select distinct status from orders. So again, group by without an aggregate function works in an equivalent way to distinct. Notice the results are the same. So I want just to show the status, but don't show me shipped more than once, even though many orders have that. Or alternatively, group them by status and then show me those. Again, same logical results. All right, let's look at the group by in conjunction then with its most common use case with an aggregate function. So I'll select the first three queries here and run them. So I have my now a use of aggregate functions, as we've seen. So count star from orders. This is a row count of the number of orders that we have. So show me the number of orders we have. The next, we're going to do what we did previously. We're going to group by status. So now we see shipped, resolved, canceled, on hold, etc. Now the two ideas together. A group with an aggregate function. The aggregate applies to the group, then not to the whole. This. We have 303 in the shipped category, in the resolved category 4, canceled 6, 4, etc. Without the group by, then we would have seen the sum total of all rows. And when we add the group, we add a category for the aggregate to apply to. Instead of the entire group, it applies to the aggregate applies to an individual group. The shipped status, the resolved status, etc. So some more examples. Recall this is just a aggregate function with no group. So let's run this by itself, and we get this result. So this will say the quantity ordered times the price of each individual order is the amount of revenue that we've had showing in our database. Quantity orders times price and summing it, right? Aggregate function, no group by. It's the sum of across the entire table. Here, grouping by order number. I'll run this query. We have the same sum, quantity orders times price each. That's the same, but now we've grouped by order number. So these are the individual line numbers, the order details. Remember, the order is the umbrella, and the order details, one-to-many relationship, are the individual lines of the order, the individual items bought under that order umbrella. So this could be representing one or many individual order details. This is the sum of that quantities under each order because we asked for order number. Notice that it's logical now to add the order number here, indeed, because that's our basic group category. So the sum of this particular order given the individual sums and the order details. Let's contrast that with the query earlier, just to recall. Without the order by, essentially the group by, without the group by, then this sum applies across the entire table, essentially a category of one thing, or a group of one thing. So another example, I'll select these two queries. So one's without the group and one's with the group. I'll just execute those two. So our first result. So again, without a group, a aggregate function will produce only a single result, a single row. Select count star of products, so the total number of products. Then we'll group by product line, so the count of the products in each product line. And that's these results here. So classic cars has 38 products in it, vintage cars 24. And if you took and added these all up, they'll add up to this number here, the count of total number of products. Individual categories here, grouped by. So refining this query where I group by product line and adding a product vendor to the group, product line by product vendor, let's run these two queries. So I'll select them and then run. So the group by just product line. So classic cars, vintage cars, etc., and the count. Now when I refine the group by adding the product vendor, I essentially create subgroups. This product line from this product vendor. So there's going to be more groups. The count should add up the same. So classic cars from classic metal creations. Classic cars from this vendor, etc. So since I'm grouping by the count of the orders, the classic cars aren't grouped together, but we can see that now we've added the vendor to our group and we can display it per vendor. So I hope you're seeing how these groups affect the aggregate functions by forming categories for the aggregate function to work on. Without a group by, then the group is the entire table rows that are selected. With a group by, then the groups form individual bins where the aggregate functions do their summary work. Let's take one warning about MySQL and the use of aggregate functions and group by. So here's my illogical query that MySQL allows. So first we'll look at select star from orders and think about that table. So I have status, many status orders shipped, and when I group by status, you'd expect to see shipped once, and etc., all the shipping status, and indeed that's what happens. So shipped, resolved, canceled, on hold, etc. However, I'm selecting rows that are outside of the group. So where does this row come from? It comes from an arbitrary row that had the category of shipped. I think probably the first one it encounters. It looks like shipped here, right? So it could have equally well been a row, the information from this row or any of the shipped categories. It puts it here, okay? SQL Server, for example, does not allow this to happen. It doesn't allow you to put in the select clause columns that don't appear in a group by, because where does it come from? This information comes from an arbitrary member of this group. MySQL shouldn't allow it, but it does. So be wary of it. Do not select columns that are outside of your group when you're using group by. Thank you.